Hello everyone. Hope you all had a great Halloween and Diwali celebration with your family and friends. And welcome to another edition of my YouTube channel, Data Science with Sam. This vlog is a continuation of the series on unsupervised learning that I started a month back. In my previous vlogs, I talked about clustering techniques. If you watched those two vlogs, you already got an idea of how data scientists apply clustering techniques to derive some of the unlabeled datasets and then apply that to their machine learning exercise. I will definitely recommend you to go back to my YouTube channel and watch those two vlogs before we move forward with this one. And don't forget to like and subscribe to my YouTube channel because more contents on machine learning and deep learning and computer visions are forthcoming. Now in today's vlogs, I'll talk about another important unsupervised learning techniques called principal component analysis. This is one of my favorite unsupervised learning techniques for dimensionality reduction. I also wrote an article on this principal component analysis, which was published in Society of Actuaries newsletter last year. I definitely shared that caption over here in the link on the article over here. So please take a look at it and feel free to DM me if you have any questions or comment on this. Now, with further ado, let's move to the next section and check out kind of a holistic view of the principal component analysis and how you can apply this unsupervised learning technique in your data science related work. So let's check it out. So what is principal component analysis? So in simple words, PCA is a method of extracting important variables from a large set of variables in a data set. When you're dealing with a big data set, you often end up, using like more than 50 variables in a data set, like whether you're performing some sort of a genome sequence or you're some sort of like a medical healthcare data where you actually have more than 50 columns in data set. So for your predictive modeling exercise, you are not going to use all those columns. So you may just use like 10, maximum 10 columns for that. So how do you define that which variables or columns have like the most significance in the data set? So principal component analysis will help you to find out those key variables. Like other unsupervised learning exercise, PCA is also a kind of like perform an unsupervised linear transformation where we take a data set with too many variables and untangle the original variables into a smaller set of variables which we called principal components. So principal components are the main key element of the exercise where it contains all the key important variables from the data. Also, it's useful when you're dealing with 3 or higher dimensional data. Like if you have like only 4 or 5 columns in a data set, you don't have to like apply principal component. That's not worthwhile. But if you have like more than 20 columns in a data set, then in that case you should apply PCA to find out the key important variables and then use those important variables in your predictive model exercise. So now let's check out in the next section that how this principal component analysis derived on a mathematics or statistics standpoint. What are the key elements which you should know when you're performing principal component analysis in your machine learning work? So let's check out that in the next section. As mentioned in the previous section, principal components are the combination of original variables. So when you perform PCA, we build those set of new principal components based on the original key variables, which are nothing but the linear combination of the original key variables. Often we ended up having a less number of principal components in comparison to the number of original variables. Now, if you see the picture here, the plot on the left showing the major variances of the two variables, but it's very difficult to understand that how the data points are dispersed. So for that, we have to perform the PCA, and after you perform the PCA, you found out two principal components such as PCA1 and PC2 show the majority of the variances. So if you follow the PC1 direction, you can actually find out majority of the variables in this PC1 direction contributes to the variance of the data set, and also the variables contributing to the PC2 component should also be considered for the predictive modeling exercise. So any variables which are in this PC1 and PC2 direction should be considered for the predictive model building exercise. So that's the main significance of PCA, to find out those two variables, for those variables which are contributing to those principal components showing majority of the variances, and applying those variables for the later stage of the machine learning exercise. We also need to remember there is a very important statistical formula related to covariance, because as we all know, covariance is the measure to give you that how much the dimension varies from the mean value with respect to each other. So that means if you're trying to find out a covariance of a certain data point along a 2D dimension, x-axis, y-axis, so you follow this formula where xi and yi represent the ith value of the x and y axis data points, xm and ym are their corresponding mean value. So when you perform the covariance, you subtract them from the original value, then perform the summation, and then divide it by the number of data points. So the reason we perform this covariance, because it's very important to understand the covariance of a data set. That will be helpful to in the later stage of the principal component exercise. Now, the next very important statistical measure is eigenvector, because eigenvectors are kind of a set of vectors that satisfy the linear system equation. Like here, we are actually measuring the linear combination of different columns or the variables, right? So the linear systems equations also satisfy the eigenvector equation, which is AV equal to lambda V. Here, A is n by n square matrix, V is the eigenvector, and lambda is the corresponding eigenvalue. So the eigenvalue denotes the variance measure. It's like for any data points, if you have like a highest number of eigenvalue, that means that particular variable, that particular variable giving you the majority number of variance in the data set. Like for example, you have like a data set of 5 columns, and among 5, the third column has the highest eigenvalue. So in that case, when you perform your predictive model exercise, you need to consider that third column for your model building, because that column gives you the majority of, shows the majority of the variance in the data set. So the eigenvalue is a very important measure when it comes to PCA. So based on the eigenvalue metrics, you can define that which are all the key elements, key variables you should consider for your model building. Now, I would definitely recommend you to check the video caption where I shared the article that was published in Society of Actuals newsletter. So in that article, I provided a R code example of how you can derive eigenvalue from a data set, and based on the eigenvalue matrix in descending order, you can pick your main principal components. And it also gives you some kind of a data visualization aspect of principal components, where you can see that how the principal components varies in different direction, and how we can pick your important variables based on the direction of the principal components. So I'll definitely recommend you to check that article, because I won't be able to cover that in this short video, but just go through that article so to get an idea of how you can use our package factor extra to define to perform some sort of principal component analysis on a data set. And if you have any question, feel free to DM me on that. So let's move to the last section to conclude this video. So that brings me to an end of this short vlog on principal component analysis. As I mentioned earlier, that you should go through the article to get an understanding of how principal component analysis is very crucial, and how we can perform our package factor extra to define your principal components from a large data set and apply that for your predictive model exercise. And if you have any question, please feel free to DM me on that. And also for Python user, you can actually use some package or some libraries from the scikit-learn. Scikit-learn actually has some functions to perform principal component analysis. So it's not like that only our users could be able to principal component analysis. I mean, Python users do have certain libraries that will be useful to carry a similar sort of unsupervised learning exercise. But this is not the end of dimensionality reduction exercise. On my end, I will definitely provide you more information on SBD or other sort of dimension reduction. But I would definitely recommend you to just go through the formula related to covariance and eigenvector and eigenvalue, because that's very important for you to understand the main aspect of principal components. It's not nothing. It's not like that you just have to apply a R and Python package to perform any sort of unsupervised learning exercise. You also need to understand the underlying mathematics behind the any sort of unsupervised learning exercise. And principal component analysis is very important, because the vector transformation and eigenvalue and eigenvectors are like one of the necessary ingredients to understand, to perform the dimensionality reduction. So that's all for now. If you have any question related to principal component analysis, or if you think that there is a better dimension reduction that we should use instead of principal component analysis, please feel free to mention your thing in the comment section, because I'll be happy to cover any other dimension reduction exercise in my next vlogs. But for now, I think principal components analysis is one of the important one that's data scientists using for any sort of dimension reduction in today's world. So that's all for now. In my next blog, I'll talk about another unsupervised learning technique called DB scan. So stay tuned for that. And also, I'm bringing another exciting series on computer vision in a few weeks. So I guess people who are very much interested into computer vision or want to learn deep learning model to build computer vision application should be interested to watch those vlogs. So stay tuned for that as well. And as I always say, don't forget to like and subscribe to my channel, because more contents are forthcoming. And also, I would recommend you to DM me if you want me to cover any other data science related topics. So that's all for now. I hope you will all have a great Thanksgiving, and I hope you will enjoy the holiday season with your family and friends. So stay tuned. Till then, goodbye.